Hello students, good evening everyone. Are you getting my voice clearly? Let me check once. Let me check once. So still it is taking some time. Yeah. Yes guys, let me wait for a minute. I think few students are joining now. Background noise. Okay, for time being, let me continue this guys. The remaining part. Yeah, good evening everyone, good evening. So let us if few students are joining. So in today's session we discuss briefly about Kirchoff's laws, then the electrical power based questions as well. First, let us discuss briefly Kirchoff's laws. Kirchoff's laws. Few minutes we discuss Kirchoff's law based questions. Few minutes go ahead with the electrical energy and power based questions, guys. We'll try to focus on right, Kirchoff's laws. So laws which have developed to simplify the electrical circuits are named as Kirchoff's current law and voltage law. Actually, the scientist Kirchoff has devoted a lot to develop these laws. So what this Kirchoff's law says, first one is Kirchoff's laws. Kirchoff's laws. So first law we call it as Kirchoff's first law or Kirchoff's current law. Kirchoff's. So what is this Kirchoff's current law says? The algebraic sum of the currents at a junction is equal to 0. Okay. The statement of this says, in terms of charge you can express it as I is dq by dt. So dq by dt through the first resistor you can take it as dq1 by dt plus I2 can be expressed as dq2 by dt. Okay, and I3 can be expressed you are taking. So if you cancel out, you can write dt of charge. Right. Similarly, consider the loop direction, the path of the loop you can take in clockwise direction or anti-clockwise direction. That you can choose and you can follow. So algebraic sum of potential differences. What is this potential difference is here, if the cell is having EMF E without internal resistance, the I is passing through this resistor, potential difference across the resistor will be taken as IR1. For this is IR2. So sum of these potentials with the sign, with the proper sign will be equal to 0. What what is the meaning of this problem? I will give you the sign conventions of potential differences in different cases. Then we can take the statement of KVL. So if you have sign conventions, let us see first sign conventions. In short, you can call this PDs. After just a brief discussion of this, we'll work out numericals, guys. Yeah, if you have a cell like this, and if the current is flowing in this direction I, so that its EMF is E, so always the longer line in the cell symbol will be represented as a positive terminal, positive terminal, and the shorter one will be between A and B of the cell. If you are moving in this direction, in the direction of current, then potential difference is represented as delta V. Well, this potential difference is positive or negative. To observe here, you are going from positive terminal of the cell to negative terminal with the potential difference across the terminals of the cell. Whereas if the same cell we are having like this with the positive and negative terminals and EMF E, and the current, of course, I is traveling in same direction. If this is point A, terminal A, this terminal B, but you are moving from terminal B to A, then potential difference delta V will be taken as, when you are moving from B to A means negative terminal to positive terminal, potential difference will be taken as positive. And what is that? Is terminal potential, that is nothing but E. Potential difference is nothing but terminal potential here, terminal EMF or terminal potential difference, it is E. This already we have this. If you observe, as current is moving from A to D, we have to mark this is higher potential and lower potential, because current always flows from higher to lower potential, and it is moving from D to C, then from C to B direction. So here for this resistor, this will be higher, this will be lower potential, and of course for a battery this will be positive and negative terminals. Okay, when you are taking the loop in this, what is that, clockwise direction, so that is, if you apply KVL, apply KVL, differences across every element in a closed loop, the algebraic sum of potential differences, PDs means potential differences across every element in a closed loop, is equal to 0. This is called Kirchoff's voltage law. So algebraic means by taking sign into consideration. So that is sigma delta V is equal to 0. This is the mathematical way of representing Kirchoff. Difference will be plus. And for a resistor, potential difference is current through the resistor into its resistor. There is an when you are the path is this, from C to D there is no element, from D to A there is an element called resistor. So here we are going from negative element to negative potential to positive, so plus potential is IR2. That's it, there is no other 2. This you can simplify and you can write in different other ways. Plus R2 is equal to 0, or you can also write this as by taking minus sign out, you can write E minus of I into R1 plus R connected in a circuit with a resistance of 9 ohm, with the resistance of 9 ohm as in figure. The current and potential difference between the points P and Q are, the current points P and Q are, so draw the circuit. To point Q, this is point P, this is point Q. Between this again one more resistor is connected like this here, right? So the values are given like this. This is 1 ohm, it is 4 volt, and this is 8 volt, this is 9. Replace these two cells with a single cell by using the combination of cells concept. And how these cells are connected? They're connected in series, but they are connected in supporting manner or opposing manner. To understand that, so this cell is giving current in first cell is giving current towards the right, and the second cell is giving current towards the left. So they are connected in opposing manner. So effective EMF of these two, you can take it as difference between the EMFs, and we can replace it. That is one way of doing it. Okay. But now here, how to find current and potential difference by using Kirchoff's laws. So if you apply Kirchoff's law to the closed loop, so you write down here under this Kirchoff's voltage law to P. Let us mark some points here. This is P, this is Q, this is PQ, R, this is. Now apply KVL to PQRSP closed loop. Then what you will get? First mark the current and the signs, because this 8 volt cell is potential EMF is more than 4 volt. The current due to this will be larger. This you should have in mind logically. So current due to this will be relatively more, so that will be flowing in the entire circuit. So the current direction will be this. You have to mark the current direction first. The resistor, 1 ohm resistor, as current is moving to the left, and you have to keep in mind that current always flows from higher potential to lower. You have to mark higher and lower, means plus minus, and again from S to R, here plus minus. R to Q, no element. From Q to S, when we are moving, here also plus minus, you mark it. For the cells, for 4 volt cell, minus back in this direction. So first, starting from P, you are moving from minus to plus of this resistor. So potential difference is plus IR. We will get 12I is equal to 4. Or I is equal to 4 by 12, or 4 ones, so 4 3s you can cancel, so it is equal to 1 by 3 ampere. So this gives you the current. From Kirchoff's voltage law, we have calculated current. Very good. Now this is first part. What is second part? How to find the potential difference between these points P and Q. If you can Q, between P and Q, between P and S and Q and R, there is no elements. You can say the external resistor R, which is equal to 9 ohm, is connected in parallel to this. Whatever potential difference between P and Q will be same potential which is dropping across P and Q, the same amount will drop across R and S also. So potential difference, or the question is the potential difference VA minus VB I think just I'm checking the live chat. Is there any messages? Just I'm checking. Yeah. 1 second, guys. If potential difference in the given figure is actually, this is one of the previous year's question, guys. The figure is this. We have a point A, and it is maintained at a potential of VA, and it is connected to a resistor and then to a cell. At the left is higher and right is lower for the resistor. Of course, for a battery this is positive negative terminal. Again, as current is flowing here, you can say this is positive and a negative for the another resistor. Now if you apply KVL, Kirchoff's voltage law, potential here if you take it as VA, and for the resistor, as we are going from plus to minus, it is potential difference is negative, and it is IR. I is 2, R is 2, 2 into 2, 4. Now for cell, we are going from plus to minus, so it is minus, its potential difference is 3 volts. And again for this resistor, we are going from plus to minus, so it is again minus, so its potential difference is IR. I is 2, R is 1, 2 into 1 is 2, and as current is going from higher to lower, minus VB, so it is equal to 0. This is how you have to write the Kirchoff's voltage law equation. Okay, now on simplifying, minus 4, minus 3, minus 7, then minus 2, minus 9, so VA minus VB, few more. Next, let me give you another related question. You can note down this question. In the circuit shown in figure, circuit shown in figure, the cells A and B, have negligible resistances. Full stop. For VA equal to 12 volts, comma, R1 is equal to 500 ohm, and R2 is equal to 100 ohm. See the figure. We have a cell of potential VA. This is first cell of potential VA is connected to resistor of resistance R1, and this is further connected to another resistor cell. We have to know what is the current here. So for that purpose, let us apply Kirchoff's voltage law. So from Kirchoff's voltage law, if you apply, this is A, B, this is C, D. Okay, apply Kirchoff's voltage law, KVL to A, B, C, D, A. Then from A to B, if you are going, as current is passing from higher to lower potential, you have to mark it as plus and minus. Then here for the battery, this will be plus and this will be minus. Okay, and for the cell again, the resistor R1 again as. And if you observe the values given in the question carefully, so you can all just you will get this one. This is equal to, as it is 6 to ampere, you have to write. In milliamperes, if you want to write, you have to say 20 milliamperes. So if you multiply with the 10 by 10, 20 milliampere you will get. So that is not our interest. We want to find what is the potential difference across AB. So for that purpose we need I. So I we have got. Now VB, from the figure, VB is equal to potential difference across AB, or potential difference across R2 resistor is nothing but I into R2, which is equal to, I is how much? 2 into 10 to the power minus 2, R2 is 100. 100 means, for the circuit shown in figure, current I will be, or find the current I in the circuit. Find current I in the, find the current I in the circuit shown in figure. Circuit shown, you have to first give the sign conventions. For a cell of 2 volts, this is plus minus. For first 1 ohm resistor, as current is moving from D to C, then back to this, that means this should move from C to B. Then between B and C nothing is there, between C and D. So here as current is moving from left to right, this will be plus minus.